Hello team, today's challenge is oldest person, where we're given an array of data, names and ages, and we need to figure out who the oldest person or people are. In the case of this one here, we have a lot of data and it returns 3 different names. So our last test has a bunch, okay? The key here is that we are operating on the age, but we're only returning the name. So anytime we're operating on one piece of data and returning another, I like to use reduce for that. So over here, we're going to jump in. I'm going to add a variable. We could do it as a straight return. There is a way to change it near the end, but I like having it as a separate variable because it keeps my head straight, right? You'll see why in a second. And for this, we need that people, and we are going to reduce, okay? Now, as always, not the star, but accumulator and current, we always have those. And at some point, we are going to return accumulator, okay? But the question becomes, what is our accumulator, right? We need to know the current maximum age that we found. We also need a list of names for that age. So we should do it exactly that way. We have names, which is going to be an empty array, and our current maximum age, our current oldest age, right? In this case, it's going to be negative infinity. And that way, when I do the initial check, it will immediately blast this away with our first bit of information, okay? But we need to update this because over here we have name and age, and here we need names as an array and age. So a little bit different, okay? Now inside of here, we could do something like destructuring off of current, right? We could get name and age, or we could just destructure right in the argument. So we could comment this out and replace current with that destructuring. It all works the same, okay? But once we have name and age, we can do our tests, okay? The first one is going to be if our age is greater than our current age. Of course, anything is greater than negative infinity. So the first one will always win, okay? But it looks like this. We have if age is greater than accumulator.age, like this, then we return kind of this object, right? So we can just grab this and make some changes. We're going to return names. It's going to have our name in there, right? Because that's where we're starting. And age is going to be age. But anytime we have a property name that equals the variable name, we can just get rid of one of these. So just age to make it shorter, okay? From there, we want to test if the age is equal to the accumulator age, okay? So if age is triple equals accumulator.age, then what are we doing? Well, we're going to push the name into names, okay? So we're going to go accumulator.names.push name. And the reason that we're doing this, the reason that we're using a push is because it means that we aren't changing this. We're only changing this specific object in memory when it needs to be brand new, okay? Any other time we're just pushing information into a specific part of it, which is excellent. That is a huge performance benefit, okay? Now, the beauty of this is that we don't actually need a check for less than, okay? Because if it is greater than, then it can't be less than. And if it is equals, then it can't be less than. And what would what do we want to do if it's less than? Well, we just want to return the accumulator, right? So if it is equals, we update the accumulator and we return it. If it is less than, we just return the current accumulator. Brilliant, right? Now with that, we can go down here and set our return to data.names, okay? And that gets it done. It's very fast, right? That's really all we needed. We just needed to think about how we're going to condition out, or how we're going to test against the different ages, whether someone is older, equal to, or less than the test age, right? That's what we're doing. Beyond that, the whole thing runs pretty fast. So I did this a couple ways. The first being here, right? This is the one that I just showed you. The second being a different one where I did less than and greater than and had the return be the equals, right? Which basically cut it in half, right? So anytime we're creating a new object every single time, that is slowing performance because we have to allocate new memory, right? And whenever we allocate new memory, that takes a split second. Okay, not much, but enough to cut our performance in half. And then I did a couple pipelines down here. They work, but not really performant. So one using map.groupby, the other one using object groupby. If you want, you can pause this and analyze that code. I'm not going to go through them, but they both work. The problem is that they are super slow compared to today's solution. Okay. So that's really it. We used a reduce. We threw a whole bunch of information into it. It kind of blended it up, gave us a result, which was names and the maximum age if we needed that. And then we just returned data.names. And could we extract this out to be its own function or something like that? Absolutely, right? There might be need for that if we wanted the names and the age in a different format. So something to think about. But for today, this is the solution. Again, not every solution, just hopefully one really solid solution. If you agree, if you don't agree, if you don't agree, if you don't agree, if you do agree, if you found a different way, let me know all that stuff in the comments. Otherwise, today this has been Oldest Person, which is probably me, and I will see you tomorrow.